Hello and welcome to my channel G Hardware. In this video I wanted to compare the new Thermal Grizzly PhaseSheet PTM that is, I guess, highly influenced by the Honeywell PTM7950 because it's also a phase changing material pad, and I compared it to the actually pretty famous Arctic MX4, and in this video we will find out which thermal material is the best. For this test I used my now fairly old Lenovo ThinkPad T480S because it got a pretty crappy cooling solution actually. It is equipped with a U processor from the 8th generation. Well, it's from the 8th generation, but it's cable-like refresh, so it's 40 nanometers big, but it doesn't got the IPC improvements from Coffee Lake and now the iGPU, because the 8th generation in the mobile space was a little bit weird because you got CPUs from the cable-like refresh generation and Whiskey Lake and so on. But I guess that's a good use case for these pads, because I guess for mobile devices where you don't want to actually disassemble everything to replace the thermal paste every year is a good solution for these pads, because it's a pretty nasty to actually open some notebooks. Well, on this T480S it's pretty easy to do it, but on my second Lenovo P53 it's actually so much harder, because you have actually to disassemble everything to get to the actual cooler. For this test, as I said, I used my T480S, which has been my daily driver for a while now. It's equipped with an i5 8350U, which can get pretty toasty under load. I ran a CPU benchmark on this laptop under 3 different conditions. The first test using a 1-year-old application of Arctic MX4, a second test with a freshly applied layer of Arctic MX4, and a third test using the Thermal Grizzly PhaseSheet PTM pad. For each test I monitored the CPU temperature, fan speed and clock rates over a prolonged benchmark run to see how each solution performs under sustained load. However, I conducted 2 different tests for the freshly applied Arctic MX4 and the Thermal Grizzly PhaseSheet PTM pad, but only the first test on the old thermal paste. The first test involved running the fans at maximum speed to determine which thermal material achieves the lowest temperatures and highest frequencies. The second test allowed the fan control to remain on auto to see if we would experience any increases in frequency or quieter fan operation. This dual approach provides a more comprehensive view of how each thermal solution performs in different scenarios. We tested all 3 thermal solutions at maximum fan speed. They all performed equally well in terms of temperature control, stabilizing at around 80 degrees Celsius. This shows that the ThinkPad's thermal management system keeps things stable under high loads. But temperature isn't the whole story. We also need to look at CPU frequency. The ThinkPad keeps the CPU temperature around 80 degrees, but the clock speeds vary depending on how well the thermal solutions dissipate heat. The old MX4 thermal paste made it hard for the CPU to keep its speed up under heavy loads. The CPU slowed down to between 2.7 to 2.8 GHz to prevent overheating. With the new MX4, the CPU worked better after replacing the old paste with the new MX4. It kept a higher clock rate, ranging from 2.8 to 2.9 GHz. The Thermal Grizzly PhaseSheet was the best. It kept the CPU cool and let it run at higher speeds between 2.9 and 3 GHz. In our second test, we set the fan speed to automatic. The automatic fan control reaches a limit at around 4000 RPM, even though the fan can go up to 6000 RPM, as we saw. This limit might be something Lenovo has set to balance noise and performance. The temperature stabilized again at around 80 degrees. With the fan speed on auto, we saw how the thermal solutions performed under normal conditions. The new MX4 let the CPU run at about 2.7 GHz. The Thermal Grizzly PhaseSheet kept the CPU at 2.8 GHz. I plotted the difference in frequency between the MX4 and the PhaseSheet to show how the PhaseSheet performs better, especially under different fan speeds. At maximum fan speed, the PhaseSheet outperformed the MX4 by an average of 47.88 MHz and a median of 37.22 MHz. With auto fan speed, the PhaseSheet outperformed the fresh MX4 by more, with a mean increase of 84.14 MHz and a median increase of 100 MHz. This suggests that the PhaseSheet is more effective when the cooling system isn't running at its maximum. Yeah, we saw that the PhaseSheet PTM pad from Thermal Grizzly is actually a pretty good product compared to the Arctic MX4. I know the Arctic MX4 isn't the best thermal paste out there, but the only downside is that the application of the thermal pad or PTM pad is actually pretty hard. So you have to, it's also written in the description, you have to put it in the refrigerator so that the application will become easier. But even with these tips or useful information, the application is pretty hard, so it's maybe not for beginners, but for enthusiasts which don't want to open their hardware every year, it's maybe a good solution. So at the end I want to point out one thing, that my test setup maybe isn't ideal for this experiment. Well, I did it in one day, so the room temperature should be pretty much equal between the tests, but yeah, it's a normal flat where I'm in here, so there are sometimes small temperature differences. Then I don't know how accurate actually the measurement of the temperature or the clock rates are. So I don't want to say these results are scientifically accurate, but we saw some improvements, and statistically, if I made everything right, we got a p-value under 0.05, so the result is significant. But yeah, if you have any recommendations what I can improve, please let me know in the comments, so yeah, I can improve myself and make maybe better videos in the future. Thank you.